In this video, we want to discuss the integration of the following integral. Now, this is an integral with trigonometric integrand. Now, as you can see, the denominator of this integrand is homogeneous and of the second degree in sine theta and cosine theta. So let's get started. So step 1 is to divide the numerator and denominator by cosine squared theta. So the numerator is 1, and if you divide 1 by cosine squared theta, it becomes secant squared theta d theta. Now the denominator. If you divide sine squared theta by cosine squared theta, that's going to give you tangent squared theta. The second term of the denominator, if you divide sine theta cosine theta by cosine squared theta, that's simply going to give you tangent theta. And the last term will simply give you c, because cosine squared theta over cosine squared theta is 1. The next step is to, of course, set a new variable, say x, as tangent theta. So that means dx will be secant squared theta d theta. Now, this integral can be rewritten in terms of x, and this is how it looks like. So the numerator is simply dx. The denominator, the first term is ax squared. The second term is bx plus c. C is the third term. Now, as you can see, this is an integral of a rational function, and we have explained how to deal with such an integral in our previous video. And there are 3 cases with 3 possible results for this integral, depending on the sign of a and the sign of 4ac minus b squared. We urge the viewers to refer to that video to get a full picture of how to deal with these 3 cases associated with this integral. However, if this quadratic denominator factorizes, it is usually easier to do this integral using the method of partial fractions. Let's look at a few examples next. Now, for this integral, as you can see, this denominator is not homogeneous, but it can be made to be homogeneous by using some trigonometry identity. The identity is, if we were to substitute this 1 by sine squared theta plus cosine squared theta, then the above integral will be sine squared theta plus cosine squared theta plus 3 cosine squared theta, which then becomes sine squared theta plus 4 cosine squared theta. So now this denominator is homogeneous and of the second degree in sine theta and cosine theta. So if we divide the numerator and the denominator by cosine squared theta, we will get the following integral. So the numerator will simply becomes secant squared theta d theta over tangent squared theta plus 4. Substituting or introducing a variable x as tangent theta, dx becomes secant squared theta d theta. Substituting these information in here and there, we get the following. So this integral will simply become dx over x squared plus 4. So this integral is actually of a standard form, something like this: dy over y squared plus alpha squared is known to be 1 over alpha arc tangent y over alpha. So using this result in here, we get the following result for this integral. It's simply 1 over 2 arctangent x over 2. Since x is tangent theta, substituting x in here will give you the final answer to the original integral, which is half arctangent tangent theta over 2. So this is the final answer to this integral. Now the next problem. As you can see, as before, the denominator is not homogeneous. So let's turn it into an homogeneous form by using an identity in trigonometry. By again using the fact that sine squared theta plus cosine squared theta is 1, and using this in here, this denominator can be rewritten in the following manner: 4 times cosine squared theta plus sine squared theta minus 4 cosine theta sine theta minus 7 sine squared theta, which simply becomes 4 cosine squared theta. 4 sine squared minus 7 sine squared is minus 3 sine squared theta, followed by minus 4 cosine theta sine theta. So substituting this into here, the denominator becomes this, and this is still the original integral. All we have done is to rewrite the denominator in homogeneous form. So next, dividing the numerator and denominator by cosine squared theta, the following integral can be written as we have explained a few times: secant squared theta d theta over, the first term will simply become 4, because cosine squared theta over cosine squared theta is 1. The second term becomes 3 tangent squared theta, and the last term simply becomes 4 tangent theta. By using substitution, x equals to tangent theta, then dx is secant squared theta d theta. So the following integral in terms of x can be written in the following manner: dx over 4 minus 3x squared minus 4x. Unlike before, this quadratic denominator can be factorized, and when you do that, you get the following: minus 3x plus 2 x plus 2. Now we can resort to the method of partial fraction, because 1 over minus 3x plus 2 x plus 2 can be decomposed into 2 fractions as shown. The first fraction is 3 over 8, 1 over minus 3x plus 2. The second fraction is 1 over 8, 1 over x plus 2. So by using this result, in here we have broken up a single integral into two integrals, namely 3 over 8 dx minus 3x plus 2 plus 1 over 8 dx x plus 2. Let's rewrite the first integral a little bit differently. Minus 1 over 8 minus 3 dx over minus 3x plus 2. And the second integral remains as it is, dx x plus 2. And it's clear that these two integrals are of the form du over u, which simply gives you the natural logarithm of u. So that means the answer is minus 1 over 8 natural logarithm of minus 3x plus 2 for the first integral, and 1 over 8 natural logarithm x plus 2 for the second integral. And using the laws of logarithm, these two terms, the natural logarithm terms, can be combined to give you 1 over 8 natural logarithm of x plus 2 over 2 minus 3x. And finally, substituting tangent theta for x, you get the final. So the final answer is 1 over 8 natural logarithm of tangent theta plus 2 over 2 minus 3 tangent theta. So this is the final answer to this integral. Thank you for watching.